Today we are going to learn about the bubble sort. Now bubble sort is a sorting algorithm, and you know that sorting is arranging values in an order. What are the two methods of sorting? We have ascending order and descending order. Ascending order is from smallest to largest. Descending order largest to smallest. So bubble sort is a very simple and effective sorting technique, but there are pros and cons of bubble sort compared to other sorting methods as well. So let's see how bubble sort is done. Right, to understand this, first we need to look at the features of bubble sort. Actually, the name bubble sort comes from a real world scenario. If you have a body of water, right, at the depth, tiny air bubbles would generate, and then when they come up, what happens is due to the air pressure, reduction of the air pressure, right, the bubbles become larger and larger. When it comes to the top, it is the largest bubble compared to the size that it was at the bottom. So now you can see when these bubbles come up, they become larger. So that's where the bubble sort gets its name, because you will see after we do this that we get either the largest values or the smallest values to either side of the list. So you will get, if you are sorting in ascending order, you will get the largest values to the right corner. If you are sorting it in descending order, you will get the largest values to the left corner. Anyway, largest values will be moved to one corner, just like these bubbles. They become larger when they come up. Okay, now you know how bubble sort got its name. Let's see the features of bubble sort. In bubble sort, let's take an example of a set of values. 50, 4, 10, 20. What we do is we take pairs of values in bubble sort. We take pairs of values. Keep that in mind, right? So if this is n, this will be n plus 1. So we take n and n plus 1 as a pair, right? So the first characteristic is we take pairs of values. And when we start from one end, let's say this end, we will go through the whole list to the other end. When we go from left to right, what we do is we compare these pairs. So the second feature is we compare pairs from one end to the other. All right. Okay. Now we need to do a sorting as well, right? It's not just going from left to right. Okay. If we are sorting, now you know that we are comparing. Okay. If you're comparing, what are you going to do next? If you want to sort in ascending order, you need to make sure that the lower values are on the left and the larger values are on the right. Okay. So if you compare n against n plus 1, right, you have to make sure the smaller value is on the left. So what we do is we compare the left value against the right value to see whether the left is greater than the right. When the left is greater than the right, we need to change the values, because we can't have the larger value on the left. It should be on the right. So if this is true, if the left value is greater than the right value, we need to do something called swap. So swap means we change the values. So 4 will come here, 50 will go there. Hope you understood. This process will be continued from left to right. So these are the main features. Now what if the left is not greater than the right? We don't need to do anything. It's already sorted. If you take that pair, all you got to do is just move to the next pair, right? So first it will take the first pair and then it will do a swap or not, and then it will go to the next pair, do a swap or not, and it will go to the next pair. Okay, let's try to sort these numbers. Let's start from the left. We take 50 and 4. Compare n against n plus 1. You can see n is greater than n plus 1. What do? You swap. Take 4 there, take 50 there. You swapped. Right, now you might have a question, okay, how do we do this? Now we just wrote the numbers on either side, but how do we actually do it? That's later, the swapping algorithm, right? Okay, now we have swapped. Now it's time to compare the next, which is 50 and 10. Remember, we compare only after swapping, if there's a swap needed. Right, 50 and 10, we compare. Now 50 is greater than 10, so we need to do a swap. So 10 comes here, 50 goes there. We take the next pair, 50 and 20. 50 is larger than 20, so then I need a swap. Take 20 here and take 50 there. Now the interesting thing here is, now I have completed from left to right, comparing the values and swapping if needed. At the end of this, what we call traverse from left to right, going through the list, we have 4, 10, 20 and 50, right? We can see that the 50, which is the largest value, has come to the right corner. What happens in this air bubbles concept? The largest air bubble comes to the corner and the smallest is at the bottom. Isn't that what is happening right now? The largest value has come to the corner. Okay, so we understand now how this happens. But just one traverse is not enough. This traverse is also called a pass. So one pass is not enough. Okay, let me take another example. Okay, let's take another set of values, right? 35, 4, 10. All right, let's take the first pair. 35. Left is greater than the right, so we need a swap. Well, let's take 35 and 10. Left is greater than the right, we need a swap. 10 comes here, 35 goes there. Let's take 35 and 2. We need a swap because left is greater than the right, so take 2 here, 35 there. Remember, we are sorting it in ascending order. Now at the end we get 4, 10, 2, 35. Again we see that pattern or that feature of bubble sort. We have got the largest value on the right corner. Now you see that the list is not sorted yet, right? So we did one traverse. This traverse is called a pass. So one pass is not enough to completely sort the list, so we need to go through more. One, let's do the pass 2. 4, 10, 2, 35. Now you know the procedure. We take the first pair, 4 and 10. It's already sorted, no need of swap. Take 10 and 2. Yes, left is greater than the right. Take 2 here, 10 there. Take 10 and 35. It's already in order. So no change. So at the end of the second pass, we have 4, 2, 10, and 35. Now can you see after the end of second pass, we see the second largest value on the right corner, right? Now that's how the bubble sort works. After every pass, the largest value will be on the right? So you can see pass by pass, larger values go to one corner and the smaller values come to another corner. Okay, now you can see it's not sorted yet. Let's continue one more pass. Pass 3, 4, 2, 10, 35. Now you know the pattern again. 4 and 2, we take the first pair. Left is greater than the right. We do a swap. Take 4 and 10. It's already in order, no need of swap. Take 10 and 35. It's already in order, no need of swap. So at the end we get 2, 4, 10, and 35, and you can see the list is already sorted. Brilliant. Can you see the third largest is on the right now? This is what bubble sort is. So hope you understood how the bubble sort works. Let's look at the algorithm for bubble sort, and then later we'll implement the actual programming language using Python. Okay, that's it for the first video. See you in the second video.